Hi students, myself Tanmoy Dotto, Assistant Professor, Department of Chemistry, JS College of Engineering. Welcome you all in my fifth lecture of water pollution. You know, water pollution is included in the environmental science. Today we'll discuss about the chemical oxygen demand. That means chemically how much amount of oxygen required for the oxidation of biodegradable and non-biodegradable matter. We will discuss also the COD test, what are the advantages and the disadvantages. And also we will discuss today eutrophication, that what are the cause and effects of the eutrophication. So without further delay, let's start the discussion.
Chemical oxygen demand. How we can define or what is the chemical oxygen demand? Previously we discussed about the biological oxygen demand or biochemical oxygen demand. So today we will discuss about the chemical oxygen demand. So what is the chemical oxygen demand? You know, the organic matter present in sewage can be measured in number of ways. That means the organic matter present in the sewage water or the waste water we can measure in a number of ways. The organic matter is often assessed in terms of oxygen required to completely oxidize the organic matter to carbon dioxide, H2O and other oxidized species. This is the common thing, very common thing, that when any organic matter oxidized, then what is produced? Then carbon dioxide, H2O and oxidized species will be produced, isn't it? The oxygen required to oxidize the organic matter present in a given wastewater can be theoretically calculated. If the organic compounds, then their concentrations are known, the oxygen demand of the sample can be accurately computed, but it is impossible to know the details of the organic compounds present in raw or wastewater. So finally, how we can define the COD or chemical oxygen demand? So therefore chemical oxygen demand is therefore determined by performing a laboratory test on given water or the wastewater sample using a strong oxidant like dichromate solution. So first of all, try to understand that in case of BOD, what we discussed in the previous class, in case of BOD, there was also oxidation occur, but only oxidation occur for the which compounds? The organic compounds, isn't it? But here oxidation occur by which? By the bacteria, isn't it? So that means bacteria will be able to break down the organic compounds. Bacteria is unable totally to break down the bonds of the inorganic compound, isn't it? So BOD is applicable only for the oxidation of the organic compound because the process they are occurred by the bacteria. But here COD, chemical oxygen demand, this include not only the organic compound, this will oxidize all types of compound there, okay? Because here we use the oxidant, this will be chemical solution. Generally it is the dichromate solution. So in case of COD, there we have to use the chemical solution or the dichromate dichromate solution, and with the help of dichromate solution we can oxidize all types of compounds. Okay, so this is the basic difference. First of all, you have to understand between BOD and the COD. Okay, because BOD and COD, in both cases we are measuring the dissolved oxygen in the both cases. Okay, either BOD or COD. Okay, in the both cases actually we are measuring the dissolved oxygen, either BOD or COD. But what is the difference? The difference is that in case of BOD, there are only biodegradable materials are oxidized, but here both types of materials are oxidized, as here one strong oxidant, that means here for example a dichromate solution, so strong oxidant present here. Now it is expressed in, as usual, like the previous case, that milligram per liter. Okay, as usual like the previous case, it is expressed in the milligram per liter. Okay, or also it is referred to ppm, as you know. For the simple case like the previous case also, BOD was also there, it was expressed in the milligram per liter or the ppm or the parts per million, which indicates the mass of the oxygen consumed per liter of the solution. Okay, so this indicate that the mass of the how much oxygen is consumed per liter of the solution. So this is the definition again, simply how we can define the COD. So COD is the total amount of oxygen required to chemically oxidize. This is the difference. Okay, you have to keep in mind. That's why the name of the COD, the full name of the COD is the chemical oxygen demand. So chemically oxidize the biodegradable and non-biodegradable. Okay, this is the other difference, biodegradable and non-biodegradable organic matter. Okay, so both type of organic matter, because if there is some chemical oxidizing agent like dichromate, okay, so if it is chemical oxidizing agent, so it can oxidize both biodegradable and non-biodegradable organic matter. Then we can determine that how much amount of oxygen required to oxidize the both types of compound. Okay, so generally its value will be higher with respect to BOD. So you know there is some history here that earlier potassium permanganate was used as an oxidizing agent. Okay, previously. Okay, potassium permanganate was the most common oxidizing agent, you know, in chemistry lab. There are so many experiments are there where we use the potassium permanganate as the oxidizing agent. COD values were very much lower than that of, in case of a BOD, they are only biodegradable materials are oxidized. Okay, so only their biodegradable materials are oxidized. But in case of COD, what happened, there are both types of oxygen, like biodegradable and non-biodegradable organic matters which are oxidized. So what is the expectation? The expectation is that COD values will be obviously greater than BOD, isn't it? But what happened, okay, when we used the potassium permanganate as the oxidizing agent, at that time what result we obtained, that COD values were very much lower than that of fifth day BOD. That means, what is the meaning of this? Meaning of this is that it indicated that the potassium permanganate was not very effective in oxidizing all the organic matter present. That means potassium permanganate is not effectively oxidizes all the compounds which are present in the solution wastewater. That's why we are getting the COD values lower than that of fifth day BOD value, because otherwise it is not possible, because COD is the both biodegradable and non-biodegradable, and BOD, whereas BOD is the only biodegradable. So theoretically we can't get the lower value of COD than that of BOD. So after that, oxidizing, if potassium permanganate is not suitable to oxidize all the organic matters present, then what happened after that, other oxidizing agent like different types of potassium iodide, potassium dichromate, this type of oxidizing agents then used. Okay, potassium dichromate, you know, it is also common like the potassium permanganate which we used in the laboratory, isn't it? Potassium dichromate is very common oxidizing agent and strong oxidizing agent. So after that the potassium permanganate was changed, this oxidizing agent was changed, and another oxidizing agent we use in the to measure the COD or the chemical oxygen demand. Okay, so now potassium dichromate, what I told you, that potassium dichromate was found to be the most effective. Okay, potassium dichromate is it was found that most effective. Why? It is completely oxidize all organic matter. It completely oxidizes all organic matter. It's relatively cheap and easy to purify. Okay, so there are some common cases are there that it completely oxidize all organic matter. It is relatively cheap and it is easy to purify. There are some points are there by which we can explain the what is the fruitful side of the potassium dichromate. So that's why potassium dichromate is more handy with respect to the potassium permanganate. So this may be the question, okay, that previously potassium permanganate was used. So what is the problem of the potassium permanganate, or what are the advantages of the potassium dichromate than with respect to the potassium permanganate? The answer will be potassium permanganate was unable to oxidize all the compounds. That's why the COD result was lower than that of 5th day BOD. So that's why when we use the potassium dichromate, it was found that we get the normal result. That means the COD result generally it will be the higher value with respect to BOD. And there are some fruitful sides of the COD also, like it completely oxidize all organic matter. It's relatively cheap and easy to purify. So that's why we use the potassium dichromate as a oxidizing agent. Now COD test by dichromate principle. Nowadays, you know what I told you, that potassium dichromate is used here for the test of the chemical oxygen demand. So now you know that water sample is refluxed in a strong acidic solution with a known excess amount of potassium dichromate. Okay, so first of all, water sample is refluxed in strong acidic solution with a known excess amount of potassium dichromate. After digestion, the remaining unreduced potassium dichromate, what is the amount of potassium dichromate? That means when potassium dichromate oxidize the biodegradable and non-biodegradable compounds, then what happen? Obviously potassium dichromate will be self-reduced. This is the process. If one will be oxidized, then obviously other will be reduced. Okay, so this is the complete reaction. So if potassium dichromate acts as an oxidant, then obviously it will be self-reduced. So in this way, potassium dichromate will be self-reduced. So after digestion, what happened? The remaining unreduced potassium dichromate, that how much amount of potassium dichromate was in the state of the unreduced form, there it is treated with ferrous ammonium sulfate, or it is titrated with ferrous ammonium sulfate to determine the amount of K2Cr2O7 or potassium dichromate consumed. Okay, the simple process, we apply the potassium dichromate, oxidation occur, then after oxidation how much amount of unreduced K2Cr2O7 present in the solution, we titrate against the ferrous ammonium sulfate, then to determine how much amount of K2Cr2O7 consumed. Now this gives us the oxidizable organic matter in terms of oxygen equivalent. By this process, we can understand what is the amount of oxidizable organic matter in terms of equivalent to the oxygen. So what is the test procedure? Test procedure is that at first we have to use 300 ml of round bottom refluxing flux. We have to take that 300 ml of round bottom refluxing flask. Then in refluxing flask we have to put one spatula of H2SO4. Okay, then 10 ml of sample, then 5 ml of K2Cr2O7, then 15 ml of concentrated H2SO4. This is the process. So in 300 ml round bottom flask, we have to add one by one. First of all, spatula of HgSO4, then sample of 10 ml, okay, then 5 ml of K2Cr2O7, then 15 ml of concentrated H2SO4. These all the things we have to add one by one in the round bottom flask. Then we have to add a small amount of silver sulfate. Okay, then we have to add a small amount of silver sulfate, and also we have to shake we have to reflux for 2 hours continuously. Okay, then what we have to do, we have to cool, and then what we have to do, we have to follow the cooling, and then we have to add a little amount of distilled water to the flask through the condenser. Okay, so this is the step-by-step process which we have to follow. First we have to add 300 ml of round bottom flask. We have to add these chemicals. We have to add one by one each and every chemical. Then we have to add a small amount of silver sulfate. Then we have to shake the round bottom flask, and we have to reflux for 2 hours. Then we have to cool it, and we have to add a little amount of distilled water, and then we have to shake, and we have to shake the flask, and we have to through the condenser we have to add some amount of distilled water. Okay, then we have to test what we have to test. We have to test that titrate. We have to titration. We have to continue that titrate the solution in the flask again FAS using ferroin indicator. Okay, then endpoint will be a green color to reddish brown. Okay, so this is the process. Finally we have to titrate, and after titration we'll get the result. So this is the process of the calculation, how we can do the calculation. The COD in a milligram per liter is determined by the formula. What is the formula? The formula is that COD milligram per liter A minus B into n 8000 milliliter sample taken, where A is the ml of FAS required for blank, and B is the ml of FAS required for sample. You understand, I already told you what is the FAS. FAS is the ferrous ammonium sulfate. Okay, in the last slide I discussed, I told you that it is a short form which we use. So, and there I told you also that ferrous ammonium sulfate we use for the titration purpose. Okay, so there from this equation we can easily calculate what is the COD value in the water or the waste water. Okay, so this is the overall calculation process by which we can calculate the amount of COD present in the sample. Now come to the point that advantages of the COD test. What are the advantages? So first of all, look here that COD result are available much sooner than the BOD test result. Obviously it will be the first advantage, because you know that in case of a BOD this is the very slow process. Why slow process? Because the oxidation was done by bacteria. Okay, so obviously it will be very slow process. But in case of COD, the oxidation was done by chemical agent, okay, chemical oxidant. So if the oxidation was done by chemical oxidant, chemical compound, then there is an expectation the reaction will be more faster, the oxidation will be more faster. So in this way we can take it that COD will be very fast. COD will be the result of the COD will be available faster than that of a BOD test result. This is the first advantage. Second advantage, the COD test result test required fewer manipulation of the sample. The minimum amount of manipulation required for the COD test, chemical oxygen demand to determine the chemical oxygen demand, or little manipulation occur. So where manipulation will be minimum, their result will be more accurate. Okay, so there in this case the result will be more accurate. Then the third point will be the COD test oxidizes a wide range of chemical compound. Okay, the COD test oxidizes you know that wide range because it is the chemically oxidation occur, where chemically oxidation occur there must be that maximum or wide range of the compounds will be oxidized by the by this process. Okay, so this is the another thing that by which we can expect that maximum chemical compounds will be oxidized. Okay, then it can be standardized more easily. So this is the simple case because it is the we can standardize the compound. Actually, you know, there is an by the general titration how we can standardize the sample. We can sample in this way. So standardization process is very easy with respect to the BOD process. So these all are the advantages of the COD with respect to BOD. Now there are some disadvantages also there. Okay, so now come to the point that what are the disadvantages. Okay, what are the disadvantages? So first disadvantage is this, that the major disadvantage is that the results are not directly applicable to 5-day BOD result without correlation studies over a long period of time. Okay, so this is the major disadvantage, that this result are not directly applicable to the 5-day BOD result without correlation studies. Okay, there must be some kinds of correlation studies, then only we can apply the result of COD test to the BOD test, otherwise it is not possible. One more limitation of the COD is its inability to differentiate between biologically oxidizable and biologically inert organic matter. This is the case actually, because when chemically oxidation occur, so when chemically oxidation occur, then it is very much difficult to differentiate between which are the biologically oxidizable and which are the biologically inert. Okay, so this is only possible by BOD, because BOD only follow the biologically oxidizable materials, okay, or matter. But in case of COD, it oxidizes both biologically oxidizable and biologically inert organic material. So there will be we can't differentiate between these two. This way you have to check all the things related to the COD, starting from your what is the COD, then what is the process of the measuring the COD, step by step process, how we can determine the COD, okay, why it is more the value, what is the history, why not potassium permanganate is used nowadays, what is the drawbacks of potassium permanganate, what is the advantage of potassium dichromate, and then what are the advantage of BOD over COD, and what are the disadvantages of COD over BOD. Okay, so these two comparisons are very much important. You have to check all these things, okay, one by one. And okay, now we'll move to the next topic. This is the eutrophication. Now come to the point that what is the eutrophication of water bodies. Okay, from the picture I think you have some idea about that, what is the term eutrophication related with which factor. Obviously water bodies in lake or like these things, I think it is clear from this picture. Okay, so now we'll discuss what is the eutrophication of water bodies. Okay, so first of all, the word trophy in Greek means food or nutrient. Okay, the word trophy means food or nutrient. Whereas the word oligo, meso and hyper stands for respectively rare and moderate, abundant and excessive. Okay, therefore the words oligotrophic, mesotrophic, eutrophic and hypertrophic have given used for the biologist, okay, to describe the various nutritional status of a marine or the fresh water environment. These words are used to describe the potentially available quantitative biomass. Okay, so this is the meaning of the name. Now it is the classification of lakes on the basis of nutrient or the nutrient contents. Okay, so this is related to the lakes. Obviously from the picture I think you understand there are different kinds of lakes are there. So first of all, oligotrophic lake means here low in nutrient. Okay, productivity is low, many species, low population. Okay, these kind of things are present in the oligotrophic lake. Mesotrophic means it is the intermediate level of the nutrients. Plankton is the intermediate, some organic sediment, and the moderately clear water. It is the in between the first one and then last one. Okay, then eutrophic means it is the rich in nutrients, low transparency, and high plankton, less oxygen, and showing increased sign of water quality problems. Okay, then hypertrophic means very high nutrient concentration, whereas the plant growth is determined by the physical factors of water quality problems are serious and almost continuous. So these are depending on the level of the nutrients. Okay, so if you see carefully, then you will understand that oligotrophic means it is the low in nutrients. Okay, in case of oligotrophic it is the low in nutrients. Then in case of mesotrophic it is the intermediate level of the nutrients. In case of eutrophic it is the rich in nutrients. Okay, and hypertrophic it is the very high, very high amount of nutrients present in the lake. Okay, so this type of lakes are available depending on the nutrients. There are different kinds of lake we can classify. Okay, now eutrophication means, what is the eutrophication? Eutrophication is an accelerated growth of algae on higher forms of plant life caused by the enrichment of water by nutrients, especially compounds of nitrogen and phosphorus, and inducing an undesirable disturbance to the balance of organism present in water and to the quality of the water concerned. Okay, so overall how we can define the eutrophication? Eutrophication means it is the accelerated growth of the algae on higher forms of plant life caused by the enrichment of water by nutrients. Obviously when the growth of the algae will be very first, that means there will be enrichment of the nutrients they are available, otherwise it is not possible the growth of the algae very first. Now you know that human caused accelerated eutrophication is referred to the cultural eutrophication. This is caused by the human being, so this is called the cultural eutrophication. So now it is the cultural eutrophication. Look here that in case of cultural eutrophication, this is the state of, this is the change of the cultural eutrophication, because different kinds of nutrients are coming there. Okay, so that's why there are different kinds of algae which are enriched in very high rate, very high speed, and obviously their sediments are also there. Then scenario leading to the eutrophication, that the mechanism that lead to the eutrophication to this new status of the aquatic environment are complex and the interlinked. The main cause of the eutrophication is the large input. This is the mainly reason actually that why the eutrophication occur. That means the very rapid or the first increasing of the algae, because the input of the nutrients to a water body, and the main effect is the imbalance of food web. Obviously if in the lake there is a very high amount of algae produced or reached, then what happened? There is an imbalance of the food web, and thus result in a high level of phytoplankton. Obviously there will be a high level of phytoplankton biomass in actually stratified water bodies. This can lead to the algal blooms. Okay, so in this way this become the problem. The process of the eutrophication, this is the process of the eutrophication by which actually the plankton or the algae which increase in the lake very high rate. Okay, so causes of the eutrophication, there are so many causes. There enrichment of water nutrients is the first cause, and by different way their enrichment occur. Okay, different kinds of humans activity also involved there, like runoff, like erosion, and the leaching from the fertilized agriculture areas, sewage from cities, and industrial wastewater from their nutrient present actually. So if this water mixed with the lake, then obviously there is a high chance of the increasing the nutrient in the lake, and in this way algae will increase very high rate. Okay, so sewage from the cities and atmospheric deposition of the nitrogen and breeding of the combustion gases also from animal breeding and combustion gases. Other points and non-point sources of the pollutants also available in this case. So this is the causes of the eutrophication. There are different kinds of factors are involved, which I told you that in this way there is a high chance of the eutrophication. You have to check it carefully. Okay, what we discussed till now, that the source of cultural eutrophication, that means cultural means it is the human being. You know what I told you, that it is man-made eutrophication. That means there are different kinds of nutrients are coming and it is mixed with in the water of the lake. So that's why the algae or the plankton increase very high rate. So look there, how many types of the possibilities are there, starting from the industry, starting from the house also, starting the cities, starting from the agriculture, all from all these things actually nutrients are coming and mixed with the water. So in this way cultural eutrophication is very important, and by this cultural eutrophication in a particular lake there is an imbalance of the food web are also generated. So main consequence of the eutrophication, first of all, availability of the oxygen. Obviously low volume of the oxygen due to microbial decomposition and the respiration, all life will disappear. That means if there is a high amount of algae, obviously the oxygen level will be decreased. Okay, microbial decomposition will be high, and the respiration of all other life will be problem, respiration problem or oxygen problem. A very specific smell of rotten eggs. This is the sign of the eutrophication. You know, you can check also there are some kinds of rotten eggs available from or coming from the some kinds of lakes. That means the eutrophication occur, originating mainly from this rotten eggs smell which are coming from sulfur. Okay, and now there are changes in algae, there changes, several different kinds of changes in algae population also possible there, and changes in actually zooplankton. There are different kinds of zooplankton also available, decrease in fish and decrease in invertebrates also possible, because their oxygen level become very low. So in this way they disappear. Okay, so consequency, there are direct consequency is an excess of the oxygen consumption near bottom of the water body. What I told you, the ratio of the nitrogen to phosphorus compounds in water body is an important factor determining which of the two elements will be limiting factor. Okay, and consequently which one has to control in order to reduce a bloom. Okay, this is the another factor, and generally you know that phosphorus tends to be the limiting factor for phytoplankton. Okay, in fresh waters, large marine areas frequently have nitrogen as the limiting nutrient. Okay, so healthy system versus eutrophic system. So look here, so if it is the healthy system, there are different kinds of there are so many, it is the healthy system. Okay, so what happened there, the different kinds of aquatic lives are there. Okay, and there is a balance in the overall ecosystem. Okay, but in case of where the eutrophication occur, then what happened, then this is the imbalance system. This is not the fruitful or not in this way. Okay, so you have to check all these things regarding eutrophication and the chemical oxygen demand, and that's all for today. Meet with you in the next class with a different topic. Thanks to you, thanks for attending the class. Goodbye, take care.